So what we're doing now, working with plant response to water, for example, how can we make soybeans more efficient in water use, is going to help Nebraska farmers be more efficient in their production. Can we get more yield with the same inputs, or the same yield with lower inputs even, or can we get more yield with lower inputs? So we're looking at that interaction of production system and the genetics that we can develop, identify and develop to improve that efficiency. And some of the work we're doing with national groups in soybean drought and temperature stress, and actually all abiotic stress, would relate to some of the things that are going on globally with possible influence of climate change. So, looking at temperature stress, ozone levels, too much water, not enough water, water at the wrong time. There's key developmental stages that use water. So water is an important thing, and it's exciting that what we're doing, looking both above ground and at some of the root traits to identify soybean genotypes that are more productive. And then, one of the biggest technologies, the advances in DNA technology and DNA information, and being able to link that directly with the phenotype, with what we find for any of the traits we're looking at, whether it's drought tolerance or disease resistance or yield per se in any environment, to better understand the underlying genetics of that. We couldn't do that 10 years ago even. So the rate at which technology is changing and making things more efficient and bringing together DNA information and high throughput phenotyping and high throughput genotyping, it's just pretty exciting to be part of that now. And I think the technologies and the information analysis and bringing all that together is only going to improve in the next 20 and 30 years, and that's going to be the challenges that can we effectively use all the information that we generate, and how can we apply that to the goals that we have to increase yield and food production in the world.